Inductive effect. We are going to learn a more important structural effect. Inductive effect is a more important structural effect. This effect operates through sigma bond. All of you know that covalent bond that form due to head-to-head overlapping of atomic orbital. There is a presence of two bonds, sigma and pi. Now we are going to discuss the electronic effect. Inductive effect is a structural effect. Before starting inductive effect, one should understand what is meant by polar compound and what is meant by non-polar compound. Polar compound and non-polar compound. It is depends upon the electronegativity of the atom. Consider you are having CH3Cl and consider you are having CH3CH3. This bond is made up of two electrons. This bond is made up of two electrons. What is going to happen? Cl is more electronegative. That's why Cl will pull electron density towards itself. So Cl will get a delta negative and this will get a positive. So there is a formation of charges within a molecule. That's why this is a polar molecule. And this bond is a polar bond. Here, the lone pair remains in the center. That's why this is a non-polar. Now, this creation of the polarity, it is due to shifting of this electron density. Now, if one atom, two atoms are there, shifting in this way, but if more atom and if electronegative atom is there, please see out of these two, consider this will shift up to this. So in this bond also these two carbons are there, but they will not. So it will shift towards this atom, but it is not like this bond. So this bond, again this will shift. So shifting of electron density, it is going to happen in the effect known as inductive effect. First of all, I will give you explanation and then we'll discuss the definition. I'll write down one compound for you, CH3, CH2, CH2, CH2 and Cl. Now please listen, as Cl is electronegative, what is going to happen? The lone pair which is present over here, it is shifted towards chlorine. So what is going to happen out of these two atoms? This will get negative delta, this will get a positive delta. Now this bond is polar. Now this bond is polar. What is going to happen? These two CH2 are CH2. But now this electron pair is not remaining at the center. It is getting shifted towards CH2, not like Cl extreme. Less than this, but it is getting shifted towards this. So this will become negative delta and this will become positive delta. Magnitude will be less. So here magnitude will be, if the magnitude will be 4 times, here magnitude will be 3 times. Now what is going to happen? Here, this lone pair, again it is shifted towards this CH2. So this CH2 will be minus and this CH2 will be plus. Here this magnitude will be less than this. And here, this lone pair is shifted towards this CH2. So this is the magnitude. I have written this magnitude is the stronger magnitude. With stronger magnitude, it will pull towards here. It is a little bit weaker magnitude. It is less. Now, if you will see this bond, you will see, if I'll ask you, this bond, is this bond is polar? If I'll ask you, This bond is polar? You will say yes, this bond is polar. Why this bond is polar? This bond is polar due to this bond. Why this bond is polar? This bond is polar due to this bond. And why this bond is polar? This bond is polar due to this bond. So now I'll write down the definition. Polarization in one bond due to polarization in adjacent bond is known as inductive effect. Very interesting, very important statement. What is the meaning of inductive effect? Listen, first of all, we have done the explanation. What is inductive effect? Permanent polarization. I am going to use here the word permanent. This is a very important word, permanent. Why it is permanent? Once this Cl is shifted, once this lone pair is shifted toward this, it cannot come back. So this effect is permanent. Shifting of the electron is a permanent. Once it is happened. So it is a no reversible. Once this electron pair is shifted towards this, once this lone pair electron shifted towards this, like this, like this. Please see, it is more towards Cl. It is less than the Cl. This is less, this is less, this is less. Now, another most interesting thing, this effect. So, polarization in one bond due to polarization in adjacent bond. This bond is polar due to this bond. This bond is polar due to this bond. This bond is polar due to this bond. Another most important, what are the properties of inductive effect? What is the properties of inductive effect? Properties of inductive effect, number one, this effect is a permanent effect. Number one, this effect is permanent. Number two, this effect operates through sigma bond, no pi bond. We requires only sigma bond, carbon-carbon single bond or any single bond. Then, most interesting, electron donating groups. Consider you are having CH3 and Cl. See, the electron density shifted through sigma bond, that's why it is inductive effect. Cl will get negative delta and CH3 will give. CH3 is giving electron density, that's why it is having its plus psi effect, and Cl is pulling electron density, that's why it was minus. Electron donating groups are having their plus I effect, and electron withdrawing groups having their minus I effect, like Cl, this thing. Next most important thing, we'll see the inductive effect in the charged and uncharged molecule. Just see, I have written two molecules. Here also I am going to write down one molecule. Here also I am going to write down one molecule. All of you know that O is more electronegative, oxygen is more electronegative. So definitely it is having negative delta, CH2 is having positive. So it is having its plus side, it is having its minus side. But when it will become charged, the electron density on oxygen is more. So now this oxygen is having its plus side and this CH2 is having its minus side. In this case, there is electron density on nitrogen. Nitrogen will give electron density. So if the nitrogen is having plus side, CH2 is minus side. If it will become NH3 plus, it will be deficient. So this will have its minus side and this will have its plus side effect. Please see how the scenario is changing. And last and most, as we will go as we will go away from the center, as we'll go away from the center, magnitude of inductive effect will decrease. I will prove this statement. CH3, CH2, CH2, CH2 and Cl. Dear student, please see the center of inductive effect is this. So Cl is having minus and plus. Please see the inductive effect present in these two atoms. Consider it is pulling 4 times. Now this magnitude will decrease here, it will become 3 times. This magnitude will decrease over here 2 times and here it will be 1 time. So if Cl is having negative minus I effect, this CH2 is having plus I effect. Here magnitude in between two it is more. As we'll go away from the center, please see, as this is having plus I, if we'll compare to this two, it is having plus I. But as we'll go away and if we'll compare the plus I effect, this plus I effect and this plus I effect, so this plus I effect is less. So as we'll go away from the center, either plus I effect or minus I effect will decrease when we'll go away from the center. So this is the most important inductive effect. Now application of inductive effect. When we are going to study application of inductive effect. Application of inductive effect, we are going to discuss 2 applications only. Applications of inductive effect. Which are the most important application of inductive effect? The first application is acidity. All of you know that the species which gives H plus ion in its aqueous solution, it is known as acid. Number 1, it is having 1 to 7 pH and it is having low pKa value. This is the property of acid. Now if you want to prove acid, consider this is acid. That acid, when you will dissociate, you will get acid and its conjugated base. Consider this is H plus and this is conjugated base. Now when this acid will be stronger, this conjugated base must be stable. If this conjugated base is stable, the recombining capacity with this concentrated H plus is less. If this conjugated base is stable, recombining capacity with H plus is less. If recombining capacity is be less, so more will be the H plus concentration in the solution, and more will be the H plus concentration in the solution. This is stronger acid. Now here we are taking advantage of this thing, that whether this conjugated base will be stabilized or destabilized by plus I or minus I effect, that we are going to see. For example, I'll take one example. This is acetic acid and this is chloroacetic acid. Dear student, more stable, less reactive, less stable, more reactive. Please this keep in your mind. Now if I'll dissociate it, everywhere when you have to prove acidity, definitely you have to think of conjugated base and H plus ion. Here also conjugated base and H plus ion. What is going to happen? You know that this CH3 group is having its plus I effect. You know plus I effect, electron densities go through sigma bond. Definitely it will give density to the oxygen. This conjugated base, it will give electron density to the oxygen, it will become rich. If it will become rich, it will be more reactive. More reactive means less stable. It will recombine this H plus faster. If it will recombine with this H plus faster, concentration of H plus is less. As concentration of H plus is less, it is weak acid. In contrast, Cl is having its minus I effect. It will pull electron density, it will pull electron density, it will pull. So this oxygen is negative charge having less magnitude of negative charge. So recombining capacity is there, but it is less. So as recombining capacity is less, concentration of H plus is greater. And as concentration of H plus is more, it is stronger acid. Okay, so that's why chloroacetic acid is more stronger than acetic acid. Dear student, acidity depends upon two things: concentration of H plus ion and stability of conjugated base. So in short, plus I effect will decrease the acidity and minus I effect will increase the acidity. I'll take one more example, that if you will take acetic acid, you will take monochloroacetic acid. If you will take dichloroacetic acid, and if you will take trichloroacetic acid. Everywhere you have to think for conjugated base. If you will remove this HHH concentrated, there is a presence of plus I effect. Here there is a presence of minus I effect. One time. The minus I effect 2 times. And here minus I effect 3 times. More the minus I, more is the stability of conjugated base. That's why this acid is more stronger and its pKa will be less. Another example, that CH3COOH, acetic acid, then fluoroacetic acid, then chloroacetic acid, then bromoacetic acid, and iodoacetic acid. When you will draw its dissociation, it will become CH3, C double bond O, O minus H plus. When you will draw dissociation constant of this, F CH2, C double bond O, O minus H plus. When here, then Cl CH2, C double bond O, O minus H plus. Then Br CH2, C double bond O, O minus H plus. And I CH2, C double bond O, O minus and H plus. Dear student, fluorine is having minus I, chlorine is having minus I, bromine. So these conjugated bases are more stable, and CH3 is having plus I, this conjugated base is less stable. But out of that, fluorine is more electronegative than chlorine, then bromine, then iodine. So this conjugated base is more stable. That's why it is very stronger acid. So these are the very much important application of inductive effect. One more example we'll take, C double bond OOH. C double bond OOH. And here also C double bond OOH. Consider you are having Cl at alpha, Cl at beta, and Cl at gamma. All these three are having minus I, but listen, here the Cl is very close to center, little bit away, and this is extreme away. Now, as we'll go away from the center, magnitude of inductive effect will decrease. That's why this is stronger acid than this, than this. So this is the application of inductive effect for finding the acidity. Next application, that is basicity. Basicity is nothing but it is the ability to donate lone pair of electron. If you will take CH3NH2 and here if you take CH2Cl NH2, this lone pair and this lone pair, please see here that CH3 is having plus I. So definitely electron density will increase, and when electron density will increase, the nitrogen's lone pair easy to donate. So it is basic in nature. Now what is going to happen? Cl is having its minus I effect. This lone pair is attracted over here. This effect is operating through sigma bond. So that's why it is not easily available for donation. It is less basic. In short, plus I effect will decrease basicity and minus I effect will increase basicity. So this is the much more stronger effect which is giving electron density through carbon-carbon single bond, and this effect is known as inductive effect. Dear student, in the next lecture we are going to see more application of inductive effect in the reaction mechanism and their structure. If you like my lecture, please like it, press bell button and subscribe it. Thank you.